Good morning everyone, I am Siddharth Paul and today I am going to teach you advanced maths. The first chapter is polynomials. So first we will get introduced to advanced maths. Advanced maths is for math enthusiasts who want to who like to do very well. If you are ready for advanced maths, you make sure that you are good in maths, good in calculations, fast problem seekers, and can do problem solving very easy. And the first chapter of advanced maths is polynomials. Polynomials is algebra only, but it includes mainly two phases, squares and cubes. So first of all we will learn about squares, then we will proceed to cubes. So before learning polynomials and squares, we will first need to learn some formulas, formulae which is important for the whole chapter, which are a plus b whole square. General formula is a square plus 2ab plus b square, and the value based formula is a minus b whole square plus 4ab. Likewise goes with a minus b whole square, and then we get a square minus b square. It is a factored formula. It is a factored formula. Factored formula. Why it is a factored formula? Because it is in a multiplication type. It is multiplying with each other. Then we have a square plus 2 a square plus b square, which is you know this and this, and then ab. It is in a fraction form. Okay, so now we will proceed towards solve some proofs. Before going to proof, we will first learn about identities. Identities is needed in polynomials. Before doing polynomials, we must know identities. Identities are exponential roots, as we have learned in class 7 or 8. In if you had RDR Sharma or RS Agarwal books, you may know these formulas, such as like wait a to the power m times a to the power n is equal to a to the power m plus n. When the base is same, the base remains the same and the powers multiply. Then we have a to the power m divided by a to the power n is equal to a to the power m minus n. When the base is same and divides, the power gets means subtracted. Then we have e to the power 0 is equal to 1 if a is not equal to 0. Then we have a to the power minus n is equal to 1 by e to the power n, right? Then we have a by b whole to the power n is equal to a to the power n and b to the power n. We have ab whole to the power anything n, a to the power n, b to the power n. We have this. These are our main formulas, and we will need this throughout the whole journey of polynomials. Now, while doing this, we need to also have proofs. Like, we will now start with the first question. Prove that x to the power m into x to the power n is equal to x to the power m plus n. Why? What is m plus n? As because I can say that x to the power m is equal to x times x times x up to m times, right? Then we have x to the power n is equal to x times x times x up to n times. When we multiply both this, we get x times x times x up to m times x times x times x n times, which is equal to when we multiply both of them, the number of x increases by m times also and n times also. Therefore, we put that x to the power m times x to the power n is equal to x to the power m plus n. You can also do that by simply putting x as 2 and m is 2 and no, not m as 2, m as 3 and n as 1. We can say that 2 to the power 3 plus 1 is equal to 2 to the power 4, which is 16, or we can just do 8 times 2, which is 16. Same answer comes same answer. So now I will we will your homework is show that x to the power m divided by x to the power n is equal to x to the power m minus n. Now we will do x to the power 0 is equal to 1 if x is not equal to 0. Why? The main question is why? Because we can write x to the power 0 is equal to x to the power 1 minus 1, right? And we know that x to the power 1 divided by x to the power minus 1 yes, divide by x to the power minus 1. So we can write x to the power 1 by x to the power 1. We cut both of them to get what? It cancels out to have 1. Why not 0? If x was 0, let's conclude that x was 0, then x to the power 1 minus 1 and x to the power 1 and divided by 0, it does not make sense. Undefined. That is why it is always that x to the power 0 plus 1 is equal, x to the power 0 is equal to 1 if x is not equal to 0. And you can prove the other identities by yourself. I know that. Now we will prove to go for the formulas, like prove that a plus b whole square is equal to a square plus 2ab plus b square. We can write a plus b whole square is equal to a square plus a plus b times a plus b. If you have those books, math books, there is always a multiplication form of algebra. When a binomial is multiplied with another binomial, it is important. If you haven't learned that, learn. It is needed. When it is like this, we can do a plus b, then plus b, a plus b, a square plus ab, and let this order be the same, ab and plus b square, a square plus 2ab plus b square. Hence proved. Right, now your homework is to prove that a square a minus b whole square is equal to a square minus 2ab plus b square.